All right, let's build a cladogram. So this PowerPoint is to help you fill out this worksheet. Backside, front side. So make sure you have this worksheet titled Let's Build a Cladogram. And we're going to follow along and figure out using this video. So here we have a variety of different cladograms. This is a cladogram, that's another example, this is another example, and this is another example. There's different ways to draw cladograms. What a cladogram is it a branching diagram that shows the derived characteristics among a group of organisms? Basically, it's showing evolutionary relationships. So as evolution has occurred, how are these different organisms related in that idea of evolution? The more branches there are separating two organisms, the more different they are. So we have a crocodile and a bird. One branch separating them, they're quite closely related. But the bird, a couple branches until you get to the amphibians. So they're more distantly related birds and amphibians than crocodiles and birds. Though you would think that those are more closely related, you have to follow the diagram, the branches. Okay? So the shark is the least related to the dinosaur and birds. Sharks are also distantly related to crocodiles. But sharks and ray-finned fish are actually closely related because we only have a few branches in there to get there. Okay? So to understand these, we need to understand what a derived characteristic is. A derived characteristic is an evolutionary change, a trait that is possessed by more evolved organisms. So your less evolved organisms have fewer of these branches. The more evolved organisms, they have more traits. Okay? So very simple, a little more complex, super complex. So the more branches there are, the more complex this is compared to that. The fork. So the fork between these two, that division right here, that separation. The derived characteristic is what creates that fork. This one has it, this one doesn't. So the turtle doesn't have hair, the leopard does. Amniotic eggs. The salamander does not have it, but these guys do. Okay? Well, yeah. All right. 4 walking legs. The tuna doesn't have it, but the salamander, the turtle, the leopard do. All right. Lamprey doesn't have jaws, but all of the tuna, the salamander, the turtle, and leopard do have jaws. So that idea. Okay. So that fork also is a common ancestor. So the turtle and the leopard have here a common ancestor, ancient ancestor, but a common one. The salamander, the turtle, and the leopard have an ancient common ancestor right there. The tuna, the salamander, the turtle, the leopard all have an ancient common ancestor right there. And the more branches back, the more ancient it is, the further back in time it is. Okay, so to make a cladogram, you first choose a group of organisms. Second, identify what derived characteristics distinguish them from each other. And third, draw the branching diagram, including the derived characteristics for clarification. So here we go. Here's our group of organisms. It's been chosen for you. Okay, we're going to go through each one of these and understand them a little bit more. So, second, the chart. Notice it's the same thing. Okay. Here's our chart. Identify the derived characteristics each species has. So, what does that mean? Well, let's look at the lamprey. It's not a fish, but it does live in the water. It attaches to other fish with these teeth-like thing. It chews through the skin, the scales and the skin of the fish, and it sucks on its blood until it kills it and then lets go and goes and finds another one to attach to and do the same thing. So, does it have a jaw? Can it open and close a mouth like this? No, it has a constantly open mouth like that. There's no closing and opening jaw. Okay, so yes or no? No. Does it have limbs? It's just this long snake-looking thing? No. Does it have hair? No. Does it have lungs? It lives in the water? No. Does it have opposable thumbs? Doesn't even have hands? No. Does it have erect posture? It doesn't even have a back with limbs and everything, so no. So, derived characteristics. Across that row. No, 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 no. It does not have any of those derived characteristics. Okay, moving on. Next, the trout. Well, let's analyze a trout. Does it have jaws? Yes or no? Well, you can definitely see a mouth that goes open and close and open and close. So yes, it has jaws. Does it have limbs? Well, fins are not technically limbs. Yes, it has fins, But it's not asking for fins, it's asking for limbs. So limbs like arms and legs. Arms and legs? No. Hair? No. Lungs? No. Lives in the water? No. Opposable thumbs, doesn't even have hands. So no, 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 no. So the trout has yes, no, 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 no. Next is caecilian. A caecilian, you might not even know what that is, so that's why I have the pictures here. Okay, it looks like a gigantic worm, but it opens up its mouth. So jaws, yes. Limbs, no. Hair, no. Lungs. Notice it's living on land. So lungs, yes. Thumbs, no. Erect posture, no. Turtle. Does it have jaws? Yes. Does it have limbs? I see legs. Does it have hair? No. Lungs, lives on land, so yes. Opposable thumbs. So opposable thumbs, concept we have to explain. This thumb is opposite my fingers, thus that's an opposable thumb. That's what that means. His are all kind of like next to each other. He can't like grab things like this. So he does not have opposable thumbs. All right, erect posture, he uses all 4 legs, not just 2. So that's a no. So yes, yes, no, no for the turtle. Now for the cat. Jaws, yes. Limbs, I see legs. Hair, absolutely. There, that cat cannot grab things like this, so no, not opposable thumbs, and uses all 4 legs rather than walking on the back too, so no. All right, so all 4 yeses and 2 nos for cats. Gorilla. Jaws, yes. Limbs, yes. Hair, yes. Lungs, yes. Opposable thumbs, so that's why I chose this picture. You can see that thumb, they can grab things like that. So yes. Erect posture? No. They prefer to go on all 4s. Okay. Humans? Yes, 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 to everything. So, you can do some totals down there. So the totals kind of help you know what are the most and least common. So the least common derived characteristic is the upright posture. Next would be opposable thumbs, then the hair, then the limbs, then the lungs, and then the jaws. Okay. Now, let's fill in the cladogram. Dun, 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 dun. Start with the species with the least number of derived characteristics. So the least derived characteristics. Who has the least? The lamprey, because it doesn't have any of them. 0 derived characteristics, so the lamprey is where we're going to start. All right. It shares a common ancestor with all of the species listed. And therefore, it's the corners in the diagram present the common ancestors. Okay, so filling in the diagram. The lamprey's right here. The lamprey's over here. That's the one common ancestor that all of those organisms have, that all the rest of them are going to have. Okay? Then you have the trout, who's next. All right, looking at this, who has, so that because the trout has just one, and that's the jaws. Okay, who has 2 derived characteristics? Oh yeah, okay, so here, down here, the jaws is the derived characteristic that separates lamprey from trout. Okay, next, caecilian. The caecilian has not only the jaws, but one thing it doesn't have that has that the trout doesn't have are lungs. So the lungs, the derived characteristic. The turtle now has the limbs. So limbs are what separate the caecilian from the turtle. That this common ancient ancestor did not have limbs. This one does, from which the turtle derived, from which the turtle evolved. Next is the cat. The cat has the hair that the turtle doesn't. So the hair is the derived characteristic that separates this ancient ancestor from the rest. So this ancient ancestor of turtle and cat does not have hair. This ancient ancestor of all the others does have hair. Okay? The gorilla. What separates cats from gorillas are the opposable thumbs. And what separates the gorilla from humans is the erect posture, the upright standing posture, standing on the back legs. All right, so we have now filled in the cladogram. Take a moment. Make sure you have that all filled in. Pause if you need to. Okay. moving on. So these things right here, the jaws, the lungs, the limbs, the hair, the opposable thumbs, the erect posture, with a highlight color, circle that, or highlight it, I don't care, and write derived characteristics. Those are the derived characteristics, and you kind of need to know that word because it could show up on the test. Okay? Now, these right here, the lamprey, the trout, the caecilian, the turtle, the cat, the gorilla, the humans, these are all organisms that are currently living. These are all the ancient, usually extinct organisms, but these are all the ones that are living right now. Okay, so species that are alive today. And then those branches represent common evolutionary ancestors, which, again, they're usually extinct. So here we go. We've got lots of common ancestors. So this one is a common ancestor for all of those organisms. This one is a common ancestor for everyone but the lamprey. So the trout, caecilian, turtle, cat, gorilla, humans, this is a common ancestor for all of them. This is a common ancestor not for lamprey or trout, but for caecilian, turtle, cat, gorilla, humans. There's their common ancient ancestor. Here's a common ancient ancestor for the turtle, cat, gorilla, and humans, but not the caecilian, trout, and the lamprey. All right, so I think you get the idea. Those represent common evolutionary ancestors. So again, with color, I want you to circle or highlight each one of those intersections, those forks. All right, and right over here, the same color, common evolutionary ancestor. Up at the top, circle all of those with a different color and write species that are alive today. So that this should look similar to that. And that is a cladogram. So if you can understand the different parts, understand the idea, the more branches separating them, the less evolutionary related they are. The less related they are. The fewer branches between them, the more related they are. Okay? So there is cladograms.